Hey guys, it's Shirley and Crystal here, and today we're going to be diving into the land of inverses. Stay tuned to find out more. If you don't know what functions are, go to our channel AAA to see a video on it. So, inverses, they are different from your regular functions. With inverses, one of the major things you guys should know about inverses is that the table of values are switched. So basically, the x values are switched with the y values. And so, to show this, I'll rewrite the table. So the y values will go under this x column, and then the x values will go under this y column. And now, as you can see, I have just rewritten the table of values to represent inverse function.
Now we're going to learn how to change a function into an inverse. Here we have f of x equals negative 3x plus 21. First, we have to substitute y for f of x and then make it y equals negative 3x plus 21. To solve it, we are going to substitute and change the x and y values and make it x equals negative 3y plus 21. Then we can just solve it and get the equation for what y equals. Here are the characteristics of an inverse function. Now, to tell if an inverse is a function, the horizontal line test can be used. Horizontal line test is a method used to see if a graphed function passes through more than one point. If it passes through more than one point, then it's not an inverse because it doesn't pass the horizontal line test. Also, if the inverse is symmetrical along y equals x, then it is an inverse. You can graph two tables of values to show this. Another thing is, only use f to the negative 1x notation if the inverse is a function. And finally, the domain and range are switched since x and y values are switched too. Now here we have an example. The red function is the original function, and the orange function is the inverse of the red function. We know that the orange inverse is a function because it's symmetrical along the y equals x symmetry line, which is the blue line in between them, and it also passes the horizontal line test, which is what we want.
Okay, so now that you guys have learned what inverses are and their characteristics, now we're going to show you how to tell if two functions are inverses. So in this case, we'll be using composition to find out if the two functions down below are inverses. So the two functions that we have here are f of x equals 4x minus 12 and g of x equals negative 4x plus 8. So the way that you use composition is that you substitute one of the functions in as x in the other function. So in this case, you would do f of g of x equals 4 times so in this case you would do 4 times g of x equals 4 times 4x plus 8 in parentheses minus 12. Now you can do either f of g of x or you can do g of f of x, because inverses, if two functions are inverses, they undo each other. So after you have substituted in your function into the other function, you now can simplify and combine like terms. And in this case, after you simplify, you should get f of g of x equals 16x plus 20. Now, since we got to 16x plus 20, these two functions are not inverses because inverses are supposed to undo each other. And so for them to be inverses, it would have to be f of g of x equals x. So there shouldn't be other terms or terms like coefficients and constants. Okay, and then here is an example of composition using two functions that are not linear. So we have here f of x equals the square root of 3x, and then g of x equals x squared divided by 3. And so you would go about your usual way of substituting one function into the other. And so you have f of g of x equals the square root of 3 times negative x squared divided by 3. And so you would combine like terms and then simplify as much as you can. And then in this case, these two functions are inverses because they do undo each other. So f of g of x equals x, which shows that they are inverses.